Welcome to a Supply Chain Institute online resource. One critical activity of a distribution center is order processing. Facilities receive orders, they schedule them, and plan resources such as headcount, equipment, and floor space daily or continuously. It is essential to assure pick phase replenishment to avoid idle times, and then picking routes have to be planned efficiently. Picking is all about selecting the right product and the requested quantity, with a quick inspection to prevent shipping orders with defects. Pickers capture all outbound product with the help of IT such as a WMS, ERP, or a simple inventory database. This to assure record integrity. Often, aside from picking, operators also pack and consolidate orders. This is really simulating the supply chain, where we will dare to take a deep dive into the wonders of simulating, experimenting, and optimizing the supply chain. The course is structured in 5 blocks, the first by focusing on the DC. In our last video, we learned how to create flow items from a queue without a source, how to pull specific items to a location, and finally, load an AutoCAD drawing as a layout for a background for reference. We have already replenished product to picking locations in a forward picking zone that is scalable, and have created empty skids to start the picking cycle. As in our inbound process, we will endow our 3D picking model with sophisticated and visual logic to handle decision-making and exceptions. We will also present the first questions that will lead us to our first problem set. So it's time to create a picking process, and we're going to do that by using a process flow because there's a lot of decisions that we need to make. So I'm going to create a task executor blank process flow. And the first thing I'm going to do, because there's no objects attached, since my picker is going to be this guy right here, I'm going to connect the process flow to my picker. And I'm going to change the name of my process flow. It's going to be called picking. And I'm going to start by creating a token. And remember, always add a delay process or activity just to make sure that you can audit anything that's happening there. Okay, there's my token. And I'm going to start with a task sequence. The first thing I want to do is for this guy to come pick an empty skid and then start picking. And I can do that by creating a task sequence. Remember to always include the 3 most important activities, which are create, finish, and dispatch task sequence. I'll put them right in the middle. I'm still not going to use them. Okay, who's going to be my task executor current? Because in this case the process flow is, let's say, the operator's mind, so it's gonna go to this object or whichever object is connected to this process flow, as we did with inspection. So it's gonna be the current one, and I want the label to be saved in a label called picker. Now I'm gonna middle with task sequence number. Let's test it. Nothing's gonna happen, of course. I just want to make sure that there are no errors whatsoever. Okay. Let's save. And let's bring him to the right location by having him do a little exercise and traveling and then loading. We can push it right there between those activities. Who's gonna be the executor? So task sequence, I'm not gonna meddle with that, and I'm gonna use, I could do this, for example, guys, I could use this destination, but imagine if I change the name of the queue to my queue or empties. It's not gonna work anymore. So I'm gonna use the relative referencing of objects, because and we saw that last session, I can reference this object by connecting it to a port, and I'm going to use the center port by pressing and holding the S key. If I check, there's a connection. So my destination is going to be current dot center objects first, the first port. Let's just travel. I did that by holding on the control key, remember? Okay, so he traveled where I wanted him to, and now I'm gonna load the pallet. Station, it's gonna be current dot center objects 1. And of course it's sending me a message because it doesn't know what to load. So remember, guys, that we also talked about referencing objects inside other objects. So I'm gonna use this syntax right here. I'm gonna point to the last object that exists in this location. But of course, because there's nothing in there, I'm gonna have to wait maybe 100 seconds for the products to arrive. I'm probably doing this too fast. I'm gonna set it to 20. And we're going to be able to see if he actually did pick the empty skid by stopping the model, moving the guy around, and he's putting the pallet in the right location because that's something we configured in the last session. So far so good. Now we want to go ahead and pick. Remember to save. Let's go ahead and copy by pressing Ctrl C, Ctrl V. Let's copy that task sequence. And then instead of traveling to number 1, I'm going to travel to number 2 because I'm going to connect my picking locations to my picker. And I have to check that I did it correctly. So I check my center ports and we have these locations. So I'm going to travel to my center object number 2. And I'm going to load products from my center object number 2. But of course, if I keep this, I'm going to be picking the whole palette because that's the last object inside the picking location. So I want to make sure that I pick the last object of that object. Okay. I'm gonna load it, finish. Let's see how this works. Oh, interesting. So the person actually did pick the object, but I'm guessing it's not putting it on top of the palette. So I'm gonna name my object current.subnodes2, because remember that in this structure I'm gonna stop it right there. Why do I do that? Remember that in the structure that we talked about last time, all these objects are inside the object operator. So that means if I count 1, 2, there's 2 objects. This order is called the rank. So it's my second ranked object inside the operator object. And after I see that this was referenced successfully, I want to do that with my box too. Let's see. My box right here, last box, is gonna be the current dot subnodes. This time it's gonna be the third, right? Let's just make sure that it is. If I click on the token, it's gonna show me that we have the references correctly. So I'm gonna make sure that the box is stacked on the palette. If I click on the token, it's going to show me that the reference is correct. This way, the box will be stacked on the palette. To achieve this, I am going to use the process flow activity called moveObject. It has 2 parameters, the object to move and the destination. I'm going to use my naming. It is this easy. I'm going to move the token.lastBox into token.emptySkid. By checking out my tree, I will assess that the box is contained in my palette. There. Now my box is a subnode of the skid. This is necessary once the operator finishes picking. He will deliver one package with everything that it contains. We can successfully pick product from location A, and now we want to do it with location B, C, and so on. Instead of copying these blocks of activities, we will be making this diagram a little smarter. But first, let's do some housekeeping. If you don't have a license, you can skip this step. In a picking process, you pick more than one box, rather a quantity of boxes per picking line, inside the picking list. So I will assign this quantity before I travel to the location, of course by using a label. Can we consolidate these labels into one? I will use an arbitrary value of 10 boxes per line to start. When should the picker stop picking and move on? We will need a decision here. And it is always a better practice to update the pending picking lines before making the decision. The kind of decision we will use is a conditional decide. If the line quantity, which is a label, has a value of less than or equal to 0, then the operator should quit. Else, he should keep picking. Let's test it. He picked the 10 boxes, but he was lightning fast, so I will modify the load and unload times. This way the process will occur naturally. Line quantity should be at 0. Good. To move to the next SKU, instead of letting the operator quit once he finishes picking the line quantity, we will send the flow to the start of the picking cycle. We'll create a label at the top. Let's call it pick lock, picking location. This label will determine the picking location of the picker, where he will be working. This label will determine the picking location where the picker will visit and pick, and it should start at number 1. How do I know? Let's check out the center objects of the picker. Picking locations start at 2. Every time the picker finishes picking the line quantity, the location counter called pick lock will increase by 1. This way he will visit each picking location at a time. That number will reference the center object. The station will be referenced in token.centerObjects and pick lock label within the brackets. Pick lock is the counter. I am going to test it, knowing that after picking location 3, which is the picker's center object 4, an error will pop up. Why? Because the counter will keep incrementing. Try to send the picker to pick location number 4, and of course that location does not exist. We haven't used an upper bound. We have been successful though. He's picking, visiting locations, but now we want to stop when there are no more picking locations. Be very careful with the connections of the decision point. Validate the direction it takes when true, and then the direction it takes when false. If the opposite of what you want to happen is actually happening, change the port order in the decisions menu. Before continuing, I will clarify my decisions by using good names for the activities. To decide whether to go to the next picking location or quit, I will use a conditional decide again. If the label pick lock is greater than 4, then quit by using port 1. Let's guarantee the connections are correct. We have the two cycles ready, the box cycle and the skew cycle. By doing this, we will be ready to run the full process in the next session. Today, we started a simple, straightforward process flow to direct the picking activities and manage its cycles and decisions. These are today's key concepts: FlexSim concepts in red, best practices in blue, and hacks in purple. You will find today's notes down below in the comments section. Stay with us, because next, we will use statistical distributions to better replicate real order profiles, handle process exceptions, and hand out the first problem set. Please comment. Don't be shy to request the supply chain processes you want us to simulate in upcoming videos. The more challenging, the better. Subscribe now to our channel and click that bell so you don't miss out on the next video. It was a pleasure sharing skills with you. Remember that we will go as far as you decide to go. This is Block 1, really simulating the DC. This is really simulating the supply chain, a free online resource for industry professionals. It is committed to create high-level problem solvers that will undertake the challenge of transforming their supply chain in the COVID era. Cheers!